Hello and welcome everyone. Today we are going to start exercise 5.1. Let us start with first question. So our first question is, prove that the function f of x is equals to 5x minus 3 is continuous at x is equals to 0, at x is equals to minus 3 and at x is equals to 5. So to prove this, first of all, let us remember the definition of continuity. So, according to the definition of continuity, a function is continuous at a given point C if limit x tends to C f of x is equals to f of c. If this happens, then we can say that the function is continuous at this point, right? So we will do the same for this given points 0, minus 3 and 5. So one by one let us check for these 3 points. So let us start with x is equals to 0. So at x is equals to 0, first of all, what will be the f of 0? So f of 0 is equals to 5 in the bracket 0 minus 3 is equals to 0 minus 3, right, which is nothing but equals to minus 3. Now what will be the limit of the function at x tends to 0? So let us find the limit of the function. So limit x tends to 0 f of x, which is equals to limit x tends to 0 5x minus 3. So which is equals to 5 in the bracket 0 minus 3. When we put the limit in the function, we get 5 in the bracket 0 minus 3, which we get minus 3 here. So as you can see, both are equal. Limit and the function at 0 both are equal. So we can write limit x tends to 0 f of x is equals to f of 0, right? So we can say that the function is continuous at x is equals to 0. So similarly we can prove for x is equals to minus 3 and x is equals to 5. So let us prove for x is equals to minus 3. Now for x is equals to minus 3, what will be our function f of x? Let me write the function first. X is equals to 5x minus 3. Now let us put the value of x here, f of minus 3, which is equals to 5 in the bracket minus 3 minus 3. That will gives us 5 3s are 15. So minus 15 minus 3, which gives us minus 18. So at x is equals to minus 3, f of minus 3 is minus 18. Now let us find limit of this function. So limit x tends to minus 3, f of x is 5x minus 3, so I am writing directly a 5x minus 3 here, which is equals to 5 in the bracket minus 3 minus 3. Remember, what does mean by limit x tends to minus 3 is, it is x is going towards minus 3, nearly minus 3, not minus 3. And if x goes towards minus 3, then the function goes towards minus 18. So minus 15 minus 3 is equals to minus 18. So as you can see that our limit and function at minus 3 are equal, so we can say that limit x tends to minus 3 f of x is equals to f of minus 3. So our function is continuous at point minus 3 also, right? Now similarly for x is equals to 5, let us write down x is equals to 5 and our function is 5x minus 3. So we put the value of x here, which is 5. So what we get? 5 in the bracket 5 minus 3. So it is equals to 5 5s are 25 minus 3. So we get 22, right? Now let us find the limit of the function. So we will do the same which we have done earlier. Limit x tends to 5. F of x is 5x minus 3, so I am writing directly 5x minus 3 here, which is equals to 5 in the bracket 5 minus 3 is equals to 25 minus 3, which is equals to 22. So here also f of x is f of 5 is equals to limit x tends to 5 fx. So let me write it here. Limit x tends to 5 f of x is equals to f of 5. So at the end of the question we can write that the function is continuous. We can write that the function f is continuous at x is equals to 0, x is equals to minus 3 and x is equals to 5, right? So this is our first question. Now let us move to the second question. So our second question is, examine the continuity of the function f of x is equals to 2x square minus 1 at x is equals to 3. So this is similar question to the first one. Here we have function f of x is equals to 2x square minus 1. Now we have to check the continuity at x is equals to 3. So first of all, it is well defined function at x is equals to 3, and we can write f of 3 is equals to 2 in the bracket 3 raised to the power 2 minus 1 is equals to 2 in the bracket 3 3s are 9 minus 1. So is equals to 9 2s are 18 minus 1. So is equals to 17. So our function is f of 3 is 17. Now we have to find the limit. So let us find the limit of this function at x is equals to 3. So limit x tends to 3, f of x is equals to limit x tends to 3 to x square minus 1 is equals to limit is equals to 2 in the bracket 3 square, and here also I have written 0 but it is 3, sorry for that. Okay, minus 1. So 2 in the bracket 9 minus 1, so which is equals to 18 minus 1, which is equals to 17. So our function is continuous because limit x tends to 3 f of x equals to f of 3. So now we can say that our function is continuous at x is equals to 3. Okay. So this is the second question. Now let us move to the third one. So our third question is, examine the following functions for continuity. So in this we have 4 sub questions, A, B, C and D. One by one we will check. So first of all, A, f of x is equals to 5x minus 5. So f of x is equals to x minus 5 is continuous or not, that we have to check. Now it is different from the first and second question. In the first and second question we have to check the continuity at the certain point, but in this question we have to check the continuity at its domain, okay, at every point on its domain. So for that we have to take some point in its domain. So let C be any point from domain of f, from the domain of f, right? So C be the any point from the domain of f. Now we will check the continuity condition for C, and if it satisfies, then we can say that the function is continuous at each and every point on its domain, because C is any point from its domain. It could be 1, 2, 3, 4, any point, right? So first of all, what will be the f of C? Therefore f of C is equals to, we will replace x with C, so we get C minus 5. Now we have to find the limit of this function as well. So limit x tends to C is f of x is equals to limit x tends to C x minus 5, which is equals to C minus 5. Now whatever the value of C it is, we can say that limit x tends to C f of x is equals to f of C, because you can see these two are equal. So we can say that limit x tends to C f of x is equals to f of C for the function f of x is equals to x minus 5. That's why the function is continuous. So function is continuous function at each and every point from its domain. So this was the first one, A. Now let us move to the second one, that is B. So in B, our function is f of x is equals to 1 upon x minus 5, where x is not equals to 5. So here it is the condition that x is not equals to 5. That means x is equals to 5 point is not in the domain of our function, right? So now we have to check that the function f of x is continuous at each and every point from its domain. So except 5, okay, because 5 is not in its domain. So let us start. For that we will do the similar. We will take any point C from its domain. So let C be the point which is from the domain of function f, right? So I am not writing the same thing again. So what will be the f of C? F of C is equals to 1 upon C minus 5, right? So this is our f of C, where C is not equals to 5. You have to keep that in mind. Now limit x tends to 0, limit x tends to C, what will we get? Limit x tends to C, f of x equals to limit x tends to C 1 upon x minus 5, which is equals to 1 upon C minus 5. Keep this in mind that C is not equals to 5 because 5 is not from the domain of f, and we have taken C from the domain of f. So here you can see that both are equal, these two. That's why we can say that the function is continuous function. So just because limit x tends to C, f of x is equals to f of C, that's why we can say that the function f is continuous function. Right? Now let us move to the next one, C. Here C is the function, it is not C like her, it is C, option C. It is function x square minus 25 upon x plus 5. So f of x is equals to x square minus 25 upon x plus 5. The condition for this is x is not equals to 5. I am not writing it here, but you can see from the question x is not equals to minus 5. So minus 5 is not in the domain of f. So simply we can take a point C from the domain of f. So let us take any point C from the domain of f. So we get f of C is equals to C square minus 25 upon C plus 5. By the way, you can pause the video and take a screenshot of it anytime, or you can write down in your notebook also what I am writing. So f of C is equals to C minus 5 and C plus 5. How it comes? Why I have written C minus 5, C plus 5 instead of C square minus 25? It is very simple, let me explain it. So c square minus 25 is nothing but c square minus 5 square, right? And from the identity c square minus 5 square, we can write that c minus 5 c plus 5. Which identity I have used? I have used the a square minus b square. You have learned this in class 8th or 9th. In both the classes we have learned this identity, and we have used this identity many times. So I have used this and I have write c minus 5 and c plus 5. So let me erase these things and let us continue with the limit. Now this is this we can cancel first. So what we get is equals to c minus 5. So f of c is equals to c minus 5. Okay. Now let us find the limit of the function. So let me write here limit x tends to c. What is our function? Our function is x square minus 25 upon x plus 5, which is equals to limit x tends to c. We can write it as x minus 5 x plus 5, right, using the identity a square minus b square upon x plus 5, which is equals to limit x tends to c x minus 5, and we get is equals to c minus 5. So as you can see here, we get c minus 5 as a limit of this function, and here also f of c is c minus 5. So we can write that limit x tends to c f of x is equals to f of c, and by the way c is not equals to minus 5. Okay. So as we can write this, we can say that the function f is continuous function because it is continuous at each and every point. Okay, it is continuous at each and every point from its domain. So that is C, and now let us check the continuity for the function which is given in D. So our function is for D f of x is equals to modulus of x minus 5. Now this is different. Okay, this is different from the earlier ones. In the a, b and c we have given the function, okay, which is properly defined. It is also properly defined, but we have to write it as f of x is equals to, here we have given a modulus, so we can write it as f of x is equals to 5 minus x whenever x is less than 5, and then we can write x minus 5 if x is greater than and equals to 5. Now do you know the reason behind this, why I am writing this function like this? We have already learned that y modulus of x is written as like this. Let me give you explanation of this one. So we have given modulus of x minus 5. That means whatever the value of x it is, the answer should be positive. Okay. Now suppose x is negative 2. Now if you write negative 2 as it is, then what happens? Minus 2 minus 5, which gives us minus 7. That means its answer is not positive. Okay. So to keep this answer positive, what we have to do is, instead of writing like this, we have to write 5 minus x. Now if it is negative 2, then what is the answer of this? 5 minus 2. This gives us 5 plus 2. This gives us 7, right? If it is less than 5, then also the problem is same. Suppose instead of negative, we have positive but less than 5. Suppose we have 4. X is equals to 4. Then also what is the answer? The answer is minus 1. Okay, which is also not positive. So whenever the value of x is less than 5, we have to write this function as 5 minus x, so that we get the positive answer. Okay. Now similarly, whenever the value of x is greater than 5, we have to write x minus 5, okay, to get a answer in positive. So this is the simple explanation, and you have already learned the modulus function in relation and function also. So it is easy for you. Now let us continue. So in this case we have three possibilities. First, x is less than 5. Second, x is greater than 5. And third, x is equals to 5. So one by one we have to check that function is continuous at x is less than 5, at x is greater than 5, and at x is equals to 5. So let us take case 1. X is less than 5. So write down, if x is less than 5, then let us take any point C from the domain, that means from the left side of a 5. So let us take C less than 5. So C is any point which is less than 5. Now if we prove that the function is continuous at C, that means the function is continuous at any point which is less than 5. So what will be the f of C? So first of all, what is the f of x whenever x is less than 5? Whenever x is less than 5, f of x is 5 minus x. So we have to write here 5 minus c. Okay. Now let us find the limit. So limit x tends to c. Here keep this in mind that c is less than 5. 5 minus x, which is our function, so is equals to limit x tends to c. Okay, I am writing it second time, so I am erasing this. So we can directly put the value of x here and we get 5 minus c. So for c is less than 5, we have limit x tends to c, f of x is equals to f of c for c less than 5. Okay. Now for c greater than 5, let us check for c greater than 5. So now for take any point, if c is greater than 5, take any point c greater than 5, then f of c is equals to, now what will be our f of c if c is greater than 5? It is x minus 5. So it is c minus 5. And now limit x tends to c, f of x is equals to limit x tends to c, x minus 5, which is equals to c minus 5. So here the function is continuous because limit x tends to c, f of x is equals to f of c. So in both the cases the function is continuous. Now what if c is equals to 0? If c is equals to 0, then what will be our function? First of all, if c is equals to 0, our function f of x is x minus 5. So, sorry, not 0, we have to write it 5. So at c is equals to 5, our function is f of x 5 minus x, right? Now, sorry, x minus 5. Now we have to check whether the function is continuous at c is equals to 5. So for that, first of all, what will be our f of c? So f of c is nothing but c minus 5. Okay. Now to check the continuity at the particular point c is equals to 5, we have to check whether left limit and right limit coincide. Why have to check left limit and right limit? Because it is different function for both left and right limit, right? For left limit it is 5 minus x and for right limit it is x minus 5. So it is really necessary to check whether both the limits are coincide at a point. So let me check it. So first of all, limit x tends to 5 minus, that means left limit. So what does it mean 5 minus? It means we have to take a function for x which is less than 5. So our function is 5 minus x, that is equals to 5 minus 5, that is equals to 0. Okay. Now let us take limit x tends to 5 plus, that means a function which is greater than 5. So x minus 5. Now put the value of x here, 5 minus 5, which is equals to 0, right? So as you can see that our left limit and right limit both are equal, and c is equals to 5, so we can say that f of 5 is equals to 5 minus 5, which is equals to 0, right? So here we can say that limit x tends to 5 minus f of x is equals to limit x tends to 5 plus f of x is equals to f of 5. That's why the function is continuous at x is equals to 5. So we can say that the function is continuous at x less than 5, the function is continuous at x greater than 5, and the function is continuous at x is equals to 5. So f is continuous at every point. So this is our third one. I hope it is clear to all of you. So in this lecture we have learned 3 questions. In next lecture we will learn other questions from exercise 5.1.